Hi guys, welcome to Learn Electronics Repair. I have an amplifier module here. I've had one of these before, DB Technologies. So this is out of an amplifier or active speaker, built-in amplifier. The last time I had one of these, in actual fact I had two of them here, one of them had shorted turns in the transformer. But this one, according to the customer, has a different problem. So DB Technologies Basic 400, this is the model. This is a bi-amp active speaker. This is very common with active speakers, apart really from subwoofers. So normally the active speaker will have a bass woofer and a tweeter or horn for the treble, the high frequencies. And to make the amplifier more efficient, they have two amplifiers built inside here. So one handles just the bass frequencies and sends those to the woofer, and the other one handles all the high frequencies and sends those to the tweeter, the horn. It uses an active filter on the input of the amplifier basically, which divides the frequencies into the two paths. So we have here a linear transformer. We do find this still quite a lot in amplifiers, apart from the modern Class D ones, which are digital effectively anyway, we could say. Although technically that isn't true. We have the smoothing capacitors here. You can see we have two bridge rectifiers here, 1, 2. So this will develop probably a couple of different supply rails. We'll have a plus and minus supply for the woofer, and that's these large transistors. So this is the amplifier effectively for the bass. In fact, they look like rather unusual devices here rather than just transistors. That does look like a transistor. These look like something else. And then the tweeter, the horn, is driven from this chip. So you'll often find this discrete transistors for the bass frequencies and an IC, an integrated amplifier for the high frequencies. So that's what I think we have here. Now, probably this will run on 1 voltage and this will run on another lower voltage. Let's see how many wires we have. Well, we can see we have the mains wiring coming in here. And we have 2 voltage supplies. So this is a ground. These will be symmetrical, 2 voltages of the same level. With reference to ground, we will effectively have a plus and a minus supply. And then this is another voltage supply. This might be basically a single voltage rail, or it could effectively be reference to ground. And it might be, because we're going to find out, that one is driving this and one is driving this. The 2 bridge rectifiers make me think there's one on each winding. Makes some sense. Okay, what's underneath this? Well, there's a few components on the other side. This effectively is the preamplifier and the circuitry which splits the frequency bands for the 2 amplifiers. So customer says bass is working fine, the horn is not working. And he says it's not the horn driver, so he's obviously tried this in another speaker. It is this, okay? And we need to fix it. So from a quick look around the amplifier, we have some idea of how this is going to be laid out. Possibly one of these fuses is for the power supply for this and one for this. I mean, they may be on the same power supply rail, I will add. Or more likely, one is in the plus and one is in the minus supply from here. Okay. First check, fuses. Visibly they look good. Okay. It tells us here what we have. We have positive high voltage and negative high voltage. Okay. I will, of course, just check those fuses with the multimeter. I'm going to use this little gotcha fix meter today. This is the scope meter I reviewed a week ago, thereabouts. I did comment at the time that a scope meter like this might be ideal for fixing things like amplifiers. So let's see if we can repair it, just using this basically. Or diagnose the fault at least if we have to get some parts. And there's some good news, by the way. So if you guys were interested in one of these, I'm pleased to announce that we have a competition to give one of these away. And this is open to anybody in the world, viewers of the channel. More later on this. It will be a combined promotion between my channel, Detleft's channel at Det Build Stuff, and Carlos at Retro Upgrade. And we will have a live draw on our live stream, the electronics channel. It's going to be sometime end of this month, early next month. I will let you know later. So you'll have a chance to win one of these completely free, including postage to wherever you are in the world. So now we've said that, let's see how well this works on this job. Okay, so these fuses. Yeah, that reads okay. I mean, this guy does have some idea of what he's doing. He runs a company that supplies this equipment. He does carnivals and events. So he does have some idea of what he's doing. So I expected the fuses to be okay. I think the quickest way to proceed from here is to power this up. I'm happy to do that without a current limiter, because if it was going to go bang, he would have told me. And let's just check to see what voltages we can find on here, to see if we have a supply rail. Well, these will be the ones for this. And hopefully I'll be able to find the supply to this one. These look like the speaker outputs because they're thick cables. And I know this is the speaker connection for both the two speakers. Okay. But I'm fairly confident I'll be able to find the supply voltage as well. In fact, probably the best way to do this is to put our black meter probe on ground, okay, and check the plus and minus outputs from the two bridge rectifiers. That should give us a good idea if we have both supply voltages. And it will be easier to do this from the other side of the board. So I can see this is the output from one of the secondaries on here, the center tap. On the center tap there, that is ground, so we'll use this as our ground reference. I can see one bridge rectifier here, AC in. There'll be a plus and minus whichever way round it is, and here's the other one, so we can see the AC comes in here. The track will be on the other side of the board for that pin, and again we have a plus and minus. So I'm going to measure from ground to the plus and minus on both bridge rectifiers. Okay, so we'll power on. This is ground. And then let's see what we have on these bridge rectifiers. So this is one. 35 volts positive. This should be 35 volts negative. And then the other one, we can just get down there. 76 volts positive. And 76 volts negative. So we can say both supply rails, the plus and minus 76 will be for the woofer. It's always the highest voltage because it needs more power, more wattage. And the plus and minus 35 will be for the tweeter or horn amplifier. It may be that voltage somewhere else goes through a voltage regulator, or rather a pair of them, plus and minus, and generates a plus and minus 15 for the circuitry at the end. That's quite common, so I wouldn't be surprised we find also on here there's a plus and minus 15. But the next thing I'm going to do, because we sort of know where the problem should be, is we'll go to the actual data sheet for this chip, and let's have a look to see what supply voltage pins we have. We expect to find plus and minus 35, I would think. And let's have a look to see where the signal comes in and out on here. The chip then is the LM3886T. While I'm just waiting for my computer to boot up so I can look on the internet, my other computer that is, just want to see what's happening with the LEDs here. So we have a power on and a limiter protect. Do these light up? Yes. So it powers on and then protect goes off. So that's normal, you would expect that. We have a typical application here. This is basically an op-amp circuit. So we have the audio input, the level of which is set by this variable resistor, into pin 10. This is the non-inverted input, so the output is not inverted. Pin 9, if you look, we have a resistor connecting back to the output. This is your feedback. This resistor plus this resistor sets the gain. And we have a 20:1 ratio, so the gain is around 20. You'll also see a capacitor here as well. This will pass AC, and bear in mind the output is AC. So it's like having another resistor in series with this one. But a capacitor effectively passes AC better at higher frequencies. So the higher the frequency, the lower the resistance this has, which basically lowers the gain, if you like. So I think this is there just to stop the amplifier trying to output ultrasonic frequencies above the hearing range, because there's no point in amplifying those frequencies. I think that's what that's there for. I'm not an expert on op amps, guys, but I'm pretty confident that's what it is there for. We have the output, that's just speaker, just shows a resistive load, 8 ohms. And you can see we have a plus and minus supply. This will be the plus and minus 35 that we know we have. And then we have pin 8. So this is your mute signal. It says RM, mute. And if we look here on pin 8 says mute. So if this switch was closed, holding the signal here, the voltage down towards the negative supply rail, the amplifier will be muted. Now there's no mute switch on this, but I think we need to check this anyway. Output on 3. So we can see the pins we want. And this is the actual layout, so we want to check. Do we have a plus and minus supply? Plus and minus 35. You'll notice the plus supply is actually on 2 pins. It's on 1 and 5, so you see it again. But 1 and 5 is the same supply, okay? 4 is a negative supply. Why they did that, don't ask me. Pin 8 shouldn't be held to a negative voltage, just check that. And then with the scope meter, we can have a look to see, do we have an audio signal? If we feed an audio signal in on pin 10, and do we have anything coming out on pin 3? And that should pretty much test if this is functioning. We can see the IC here. This is pin 1. So the pins go 1, then 2 is in there, 3, 4, 5. So these are 1, 3, 5, 7, 9, 11, and we have 2, 4, 6, 8, 10 down inside there. Now it's very difficult to probe inside here without shorting to one of these pins. I mean, I wouldn't want to do that on a powered up amplifier. Some of the signals are going to be easy to get to from this side. So pin 1, for example, is V+. 3 is out. But the other signals we want, 4 is a minus supply down there. 8 is the mute, and 10 is the audio in. So it's going to be easier to do this from the other side of the board. And the chip is here, so this is pin 1. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, so that's what we have. So let's power this up again. We'll go check the supply rails first. What I'll probably do now is attach my ground lid with a crocodile clip. I like to have one hand free basically when I'm doing this sort of thing. I think the metal chassis is probably ground. We can just check that actually. So I'll just go from ground, we know it's here, to the metalwork. No, it's not actually. I thought that might have been connected to the ground. It isn't. What I normally do in this case then is see if I can attach a crocodile clip. I think there's another place I can find ground actually on here, and that's on the speaker connection, because the speaker connects back to ground. And this is easy to attach a crocodile clip. So this is the speaker connector here. Okay. We know ground is here. Let's see. So this end is ground. And this end is ground. Okay, so we have a ground. So I'm just going to put a crocodile clip or a little connector onto there and attach my black meter lead. It's probably safest just to plug a little connector onto here. I mean, this is off an ATX power supply, but if we try it, fits on very nicely. And then we know this black lead is now our ground, so we can clip our crocodile clip on here out of the way. I'm not going to short anything out by accident. And I now have one hand free. I find this much easier to work. Normally, if I'm measuring voltages on any device, I'm going to be measuring them with reference to ground, so I probably don't need to move the black meter lead. Therefore, I just clipped it onto here, and it's clipped onto the end of the wire I mentioned, and that's plugged to the board. So I don't have to worry about that now. All I need to do is take the voltage measurements, and that's starting from here, which is pin 1. So let's power this up. Okay, and then let's have a look. So this is pin 1. 35 volts, okay. Pin 4 is here. Minus 35. So we know they're getting as far as the chip. Muters on pin 8. That's being held negative at 4. That does go somewhere on this board. I need to look at the datasheet to find out what voltage would mute this amplifier, but it's possibly muted. So before we start to inject signals in, let's have a look at the datasheet again. So here we are. This will tell us somewhere in here what voltage we should find on the mute pin, if it is or isn't muted. Let's have a look. Well, it says here mute attenuation, pin 8 open or at 0 volts, mute is on. We see a minus voltage on here. Let's see if we can find some sort of description of the operation of the mute. Well, we have a typical application here. This is a single supply application, but it mentions this RM. And it says RM mute resistance set up to allow 0.5 milliamps to be drawn from pin 8 to turn the muting function off. That makes me think, because we've got a negative voltage on here, it probably is. Look, RM is calculated using RM is less than or equal VEE. This is the negative supply, minus 2.6 divided by 18. Or I8, I'm not sure what it actually says. Oh, I8 current pin 8, I think. But he's basically saying where I8 is more than 5 milliamps or equal to 5 milliamps. So the fact I have a negative voltage on there makes me think this is correct, but we can prove this. So if we find the resistor connected to pin 8 and we measure the voltage across that resistor, then from Ohm's law we can work out the current flowing through it, and if it's more than half a milliamp, then that's good. Okay, so we'll test this. My gut instinct is it's fine, but hey, this is an educational video, yeah, so let's see how we can test that. We also have on this typical application the CI, okay. And this doesn't do exactly what I thought it did, but okay, I'm not always right. It's a feedback capacitor. It ensures unity gain at DC. That's because at DC, basically, no signal can flow through there. So this has an open circuit and infinite resistance, effectively. So what it's actually there for is at DC levels, the amplifier doesn't amplify. That's what it actually does. Now I've spotted that, I won't be fooled by it quite so easily next time. Okay, so I can see clearly pin 8, we know where it is, and it does go to a resistor. I'm assuming this then goes to the negative supply rail, if not through another resistor, but it doesn't matter because all we need to do is A, check this resistor to make sure it is 4.7k, which is marked 4, 7 and 2 zeros, and B, measure the voltage across it, and then we'll know if we're drawing more than 0.5 milliamps. So the first thing, how does the resistor read? Well, yeah, it reads 4.7k, so it reads what you'd expect it to read. The second thing then is to power it up and just measure the voltage across this resistor. So we're now on volts range. Let's switch this on and measure the voltage. And we have 8.32. I'm expecting it to be negative because it's connecting to the negative rail, but that won't affect the mathematics. So we want to know what the current is. We need Ohm's law. And Ohm's law tells us V, I, R in the triangle. I used to remember which way they went, so R to the right, but in actual fact, it doesn't matter which way round you put the I or this still works. Anyway, so we want to find out the current, which is I. So we cover that with our finger and we end up with V over R. If we wanted to find the voltage, it's I times R. Wanted to find the resistance, it's V over I. But this is what we want, V over R. Well, we know the voltage because we've measured it. And we know the resistance because it's marked on the resistor. And we've measured it. And we also know the voltage because we've measured it, 8.32 volts, ohms. We've got to draw an ohm. Always in volts, always in ohm. So if this divided by this is more than 0.5 milliamps, we know it's not muted. Let's find out. So 8.32 divided by 4700. Well, that's saying 1.7, 1.8 milliamps. That's more than 0.5 of a milliamp. So that amplifier is not muted. So we can discount that. Next thing then, we need to feed a signal in to the amplifier. And let's see if that's getting as far as the input to this IC. I've just connected audio from music playing on my computer. You can't hear it because the speakers are disconnected. I've connected this. We can see this is the input. So this is where the audio comes in. And then that goes on to pin 10 on this chip, which is here. So let's see if we have any audio coming in. It's under here, but I've shown you where it is. So this is the input. Yeah, and we clearly have an audio signal there. Now, the high frequency component of that should end up on here. And in fact, we do see audio on there as well. So we'd expect it to be a very low value. This is the input to this amplifier. In fact, we may not see anything here at all, possibly. We'd have to go to the other side of the resistor that feeds here. We could see that on the datasheet. But we know we have an audio signal coming into our amplifier. We know it's not muted. So we also know we have power to it. And according to the datasheet, there's no other reason why it shouldn't be working. Another thing I've noticed, actually, this is getting quite warm here, especially around this amplifier chip, which, considering there's no speakers connected to it, seems a little bit suspicious as well. You wouldn't expect the output device to get warm if there's no speaker attached. It can't really dissipate any wattage. We can have a quick look on the thermal camera. But I'm already at the point when I would say change this chip. There's nothing really else we can check. It's the heat just makes me think, yeah, there is a problem here. I have the thermal camera here. In fact, you can see that IC is still fairly warm. Let's power this up again and see what happens with it. So I'll just get a thermal camera pointed at the IC. You can see it there. Let's switch it on. And that is warming up. I mean, that is the hot thing. I'll just take the camera a little bit further away. Yeah, this general area, there's a lot of heat. And the heat goes to this chip, okay? So that's another good indication this has a problem, considering there's no speakers attached. Right. We can and should, of course, just check to make sure that this thing isn't actually working. This customer is pretty good, as I mentioned. He can handle a lot of basic repairs himself, and he tells me it's not the horn speaker. But you know, because this is getting a bit warm and we do have an input, and I'm just going to check this. So I'm back on the scope. This is pin 3. This is the output pin, which goes to the connector here. So we'll go on to the connector. This is the connector to the speaker. We'll just check this actually. It should go here. Go on ohms range, just have a quick look. So from here to pin 3. Yeah, it does go there. So we'll go back onto the scope. Okay. What have we got? Pin 3. Well, we have nothing, so we know that the amplifier chip definitely isn't working. If it hadn't have been this customer, I would have probably checked that earlier, but I do trust this guy pretty much. He brings me quite a bit of stuff to repair. So we're going to need an LM3886T, and that should fix this. I don't see anything else around here that would cause this problem. I don't think I'll have these. I can check. Well, guys, I don't have these in stock. I'm on AliExpress. I can see a few for sale. Although these ones look cheaper, they are not really. Look, you have the shipping on top of that, where that's with free shipping over €10. I would order 2 of these anyway. So taking into account the shipping, there's probably no real difference. This one has 256 sold and 5 stars. I mean, that also has 11 sold 5 stars, but this actually works out cheaper, as you can see, than total. 87 reviews. Look, this guy says he has 1 from 8 not working, but they are 20 years old, he says. Apparently, yeah, a lot of people seem to recommend this seller, so I will go with that one. I'll order 2 of these, partly because it's always prudent to do that. Secondly, because I'm going to charge the customer for the parts anyway and keep the other one if it's good. And thirdly, because this is the second one of these amplifier modules he's brought me to repair. So if he's got 2, then no doubt he's got more than that. So we'll definitely order another one. In fact, actually, I might just order 3. I hope you enjoyed that, guys. Nice little bit of fault finding there for those of you who are fairly new to this. Hope you followed that. If you had any problems or you couldn't quite follow where I was going, just ask, comments below. If you would like to suggest why I should have done this in a different way better, comments below, because you know, everybody has the opinion and I can take it whatever yours is. Okay, I look forward to seeing you all soon on another Learning Electronics Repair video. Ciao for now, guys.